My name is Safak Sonmez. I'm a postdoc at Université Laval. First of all, thank you very much, Shane, for a good trailer for my presentation. And I would like to start with my talk here, but first of all, a big apologies because I didn't bring a nice data to present today. Therefore, I was just itching my head in my office, and I was asking me, what should I present? What should I present? And then I received a very good, encouraging email from George, thank you, George, which inspired me to prepare this presentation. So, first of all, I would like to go back to the first Metal Earth meeting, which is organized in 17th of October. What I have presented that, I presented where I'm gonna do my study in the Southern Abitibi, right? Mouse is working, oh, yeah. The Southern Abitibi, especially on the Destor-Porcupine Fault Zone, right? And I asked several questions as well. So what are the major deposits in Timmins, right? So I heard this question, why we have major deposits in Timmins. I heard these questions a lot today because it's very important. We don't have big deposits, for example, in the Matheson region. And if these deposits, they have similar source characteristics, and are these mineral systems interconnected each other? So we need to investigate these big questions. So how? This is very important for us because if we would like to constrain these events carefully, we need to trace them by particular analysis, like oxygen isotope study and hydrogen, and also uranium-lead dating and multiple sulfur isotopes. So, therefore, it's good to mention about the history of the fluids with an approach of the geochronology and isotopic compositions, right? So I know everyone here, it's an expert of the district, right? And I would like to humbly mention about the magmatotectonic events, the summary of the magmatotectonic events. So first, we have volcanic rocks, okay, and the intrusive rocks around 2695 to 82, which is overlapping with the extension. And then we have like sedimentation, which is coinciding with the D1 or D2 shortening. After that, we have Timiskaming formation around 2680 to 2665 million year, which is also coinciding with the cyanide and monzonitic intrusion. That's great. And this is also important for us because this is overlapping with the extensional event there, which might have some mineralization. I'm gonna go there soon. And after that, we have main shortening, which is related to D3, and followed by D4 and D5 events. Okay, good. How about the mineralization events along the Destor-Porcupine Fault Zone, right? This is very important for us. So during my study, actually, I'm focusing on the quartz carbonate veins, but also intrusion-associated veins are important for us, right? So let me try to summarize. In the Timmins district, so we have some molybdenite ages in McIntyre and Dome Mine, which is 2670, okay? And we have also some zircon hydrothermal rim age dating from Holy Pond Mine, which is 2643. And if you compare these two ages, the zircon age, it's relatively younger than the molybdenite age. And we have also other ages, right, like monazite age and around 2640, and also argon-argon ages from Fuchsite, which is quite younger. And how about the Matheson region? So we have molybdenite age, which is 2671. And also we have another monazite age, which is related to the deformation event around 2657. Okay, so these are the main mineralization events along the Destor-Porcupine Fault Zone. However, regarding the radiogenic dating, I would like to ask some questions. First, ages come only from the largest mines, okay? And lack of age dating, we have lack of age dating. We don't know the other prospect or occurrences ages. So this makes it really hard to understand the constraint, what is the main mineralization event along the Destor-Parker fault zone, right? And we have no radiogenic age from the cyanide-hosted quartz veins, because this is also important. It might be related to, intrusion either, or might be related to orogenic event, which was, overprinting the intrusions, right? Therefore, my first aim is dating these mineral systems, okay? And I will try to use xenotime and monazite, because these are the most important candidates for uranium lead dating. I hope I can find some of them from these deposits, then we can understand the age of the mineral systems along the Destor-Parker fault zone. Okay, so chapter 2, stable isotope. As Shane mentioned before, I would like to go for that with the same way. As everybody knows here, right, orogenic deposits, they are related to crustal fluids, and there can be also magmatic derived fluids, partially essentially for ore forming process, maybe not. This is a big discussion. I don't want to dig deeper for this talk now, because this is completely different. But what I would like to say, I would like to grab your attention. So regarding the oxygen isotopic compositions, okay, in Val-d'Or region and Timmins region, look at this one. These are quite distinct, right? You can also recognize this. What does this mean? We should understand that. So this means maybe there can be two different deep crustal sources, okay? Or, you see, the two different, this is Timmins related ore deposits, this is Val-d'Or region ore deposits. And this can be also, maybe the fluid composition might change during the fluid migration, right? It can be also possible. Another gap in this study is we need to fill. We don't know the quartz veins composition hosted by cyanide. Therefore, we have some problems, right? So we need to understand what is really going on. What are the source characteristics, all of these systems there. So problem number 1, we have scarce data distribution. So we cannot constrain it very well, very robustly. The reason is, as you can see, in Timmins and in Madison, we have oxygen isotope, yes, but what is absent along the Destor-Parker fault zone, we cannot trace it. And we have also some problems about the sulfur source in the region. So we need to constrain the source of sulfur. This is important because maybe we can understand the fluid rock sulfidation reactions for these gold-bearing systems. That's important. So what is my aim, as Shane mentioned also? So we need to carefully categorize all of these mineralization styles first. Cyanide-hosted quartz veins, or you can say intrusion-hosted quartz veins, versus quartz carbonate veins, which is related to orogenic phase. And the second thing is we need to identify the mineral pairs to estimate the temperature of these fluids in different mine sites, right? So I'm gonna use the same mineral pairs like quartz tourmaline, quartz chloride, quartz cerussite. This is important because these are the most favorable candidates, right, to estimate the temperature. For example, here, there are some examples like chloride and quartz oxygen isotopic compositions and tourmaline versus quartz. So we can estimate the temperature and we can also use some equations to find the equilibrium of the fluid for these mineral systems, right? And I'm gonna do also bulk and in situ sulfur isotope studies from different minerals like pyrite, arsenopyrite, chalcopyrite, and pyrodite. I don't want to read everything because you can already see, so this is good. And sulfur minerals, basically, let's say. Okay, so let's talk about the project status. So this is my aim, what I'm gonna do. During this summer, I started my position here in August, so I spent almost 6 or 7 months So I visited different mine sites and the core shacks from different companies. I worked with Agnico Eagle, McEwen, Pan American, and I visited all of these prospects, and I collected drill core samples, and I also discussed about the geology and the mineralization styles there. And immediately after my fieldwork, I also went to the Royal Ontario Museum to collect more samples. You can see the distribution. And also, I have some samples from the University of Toronto, from the big mines like Hollinger and McIntyre. So when I put everything or plot it on the map, so you can see we can fill all of these gaps in terms of age dating and sulfur isotope characteristics. Actually, these points are showing where I worked on during my field work, but I have multiple samples, okay? So, but within this scale, it's impossible to show everything, so, but this is, I think, quite enough to show, okay, we can constrain the source of the fluids along the Destor-Porcupine fault zone. I would like to show some of my fancy samples. I don't know if you find it fancy because it's quite new for me. I am a new person here, so I have not faced with these samples before. So these are the orogenic characteristics veins from different locations. From Holt, for example, from Holloway, Taylor, Grey Fox. We heard these mineral systems during this morning, during the different presentations, right? And also, as I mentioned, we have different kind of vein styles, right? Like cyanide hosted here, highway, which is here, for example. And also some different flavored, like epithermal, I would say, but I don't know, maybe I am speculating. You can tell me in a clear way. But the type of the quartz is quite different, right? So we need to understand about the nature of these veins in terms of age and stable isotope. So work schedule. So dating, this is my first aim. So we are waiting for the sections, thin sections, and my aim is dating these deposits. I hope I can find a good candidates to date. And so I would like to also date some of the molybdenites. I hope I can date because when I check the molybdenite results, they are quite overlapping, but the uncertainty is quite high. So I'm not sure, we are still discussing about that, but I have already contacted with the lab, and maybe I can date them. One of them is Gibson, which is this one here. So you can see this black stuff, which is molybdenite, and I have also more material. So it is good to date. And also Froome mine, which is also located in Matheson. So it also has some molybdenite, and we don't know the connections between Gibson and Froome in terms of this molybdenite mineralization. This molybdenite is also important because it is correlated with the gold. So if we date the molybdenite, for example, we can understand the age of the gold. And also stable isotopes. So we are trying to do some stable isotopes, as I mentioned, and Shane mentioned as well. Sorry, I am repeating, but yeah. Quartz samples, these are the candidates for stable isotope for us, and we are gonna start our analysis, hope in the following days or weeks. And also, I'm preparing some of the pairs in order to estimate the temperature. And also we are gonna do some bulk stable isotopes from the sulfur minerals, and we are still preparing the samples, but we need to do also in situ analysis from the clarified or examined thin sections, because it is also important. I would like to thank to all these companies and all of these researchers and geologists, and not in a particular order, but they helped me a lot, and thank you very much for all of these nice moment, nice time during the field. I felt I was at home, and I deeply appreciate for your attention, and feel free for your questions. Thank you.